let us review what we have learned about the Git distributed version control system, some best practices that seasoned software engineers follow, and discuss some of the recommended reading. We examined the clone command that is designed to create a directory containing a working copy of the files from an existing repository and a .git directory. Another commonly used scenario is to create a local copy of a repository by the use of the git init command. This directly creates a .git folder in our current directory. Then we can proceed to use the add and commit commands to create new files in the repository. Remember to do only one of these, either the clone or the init, and not both. Git status is really handy to see what Git thinks is going on. It is a good habit to do this frequently. Another command that should be used often is commit. In Git, commits are really cheap and we should do them often. When you commit, you must provide a one-line message stating what you have done. For example, this is a terrible message. A better message is this. Commit messages can be very useful to yourself as well as to your team members. You can't say much in one line, so commit often. Note, if you forget to type in a message, Git will open a text editor so you can write one. Be careful if you add to the staging area and then make more changes. The file can appear as both staged and unstaged. If you tend to do this often, I would suggest doing the git commit -am command, which does both an add and a commit in one. Diff is a useful command to see what is modified in your working directory but unstaged. Reset is there to unstage a change on a file before you have committed it, while checkout lets you unmodify a modified files. Note, these commands are just acting on your local version of the repository. To see all the changes made to your local repository, you can use the log command. A branch represents an independent line of development. You can think of them as a way to request a brand new working directory, staging area, and project history. New commits are recorded in the history for the current branch, which results in a fork in the history of the project. The git branch command lets you create, list, rename, and delete branches. The merge command lets you take the independent lines of development created by git branch and integrate them into a single branch. Pull is important when you are working with others. Let's look at this command in more detail. All repositories are equal, but it is convenient to have one central repository remotely located in the cloud. Here's what you normally do. You clone the current head from the remote repository. A head is a reference to a commit object. You then make your changes in your working directory. If at any point you want to revert your changes, you use the checkout command. Then you stage your changes in the staging area using add. You then commit your changes to your local repository. Now you can also do both steps together using a commit-a. At any point during this process, the diff command will tell you the difference between the working directory, the staging area, and the repository. Now this part is important. You can then check to make sure that someone else on your team hasn't updated the central repository since you got it using the pull command. If the central repository has changed since you got it, it is then your responsibility to merge the two versions. This is a strong incentive to commit and upload often. Now, Git can often do this for you if there aren't incompatible changes. Finally, you upload your changes to the central repository using a push.